All right, so let's go back to the custom solver now that we run through how you can build your own solver here. I'm gonna hide this and let's unhide the custom solver here. Let's press F to focus and go back inside there. So custom solver, boom, and this is the one. And let me start from the beginning. So, all right, so we have the mesh animation here, and let me just show you here and forget about texture there, because I'm really not using that. But what I did, I grabbed the top part and then I just changed the pivot point here on the back, so it's easy for me to animate on this axis here. And basically that's what I did. Is very simple. So if I open the graph editor, as you can see, it's nothing really complicated at all. And then I brought this into Bifrost, so I have this expression here, and you can see, and that basically what it does, it just brings everything that is under this group here. So if we look at this now, so you can see there's just two pieces here, and now we have two pieces under the transform group, right? I merged that so I can see the different attributes that this mesh has here. And then if we look at the point count here, I think it's around 50,000 points here, right? And if I disintegrate this mesh, it's a little bit low res, so I just increase the point count here to with the subdivide mesh from AW, I believe is his name. Hopefully I'm not mispronouncing that, but I will also highly recommend getting his library. It's very, very useful, and I believe, where is that? Is somewhere here. Now I'm getting, I know it's somewhere here, you probably already saw it, and I just can't see it myself. Right there, yeah, AW. I highly recommend getting his library. It has great notes as well that for us to use. And I just basically just subdivide this mesh twice. And if we look at that now, you can see from the wireframe that we have a lot more points. And if we check the point count now, it's like around 800,000 points. And that, I mean, I could go higher if I wanted to, but this, it was a good kind of like intermediate point. And you can see that that is animated, right? So it's bringing the animation, and basically all this right here, for the most part, is the same that we already covered. So I'm gonna go very quickly now. But I set up a mask. I initialize the attribute with a value of 0. Then instead of calling this weight, I call it noise. But again, you can call it whatever you want. And if we go inside the noise here, I did basically the same, but instead of using the fill, I use the fractal noise, which is the same. Instead of like sampling, right? Because we need the field, we need to sample the field, just use the noise that it comes. You need to get just the point position from the mesh here, right? And then all this I did end up using because I basically I'm just offsetting C and I'm animating. You cannot tell, but I'll show you that. But again, this was no use. Then I'm using a clamp again, so it's other than 0, and then I'm using a fall off here as well, and then I'm multiplying this follow by this noise. So if we look at this very quickly here, and let me just go from here and we preview. Check that and say noise. And let's look at this now and go back and turn off this. You can see what the noise is doing. You can see if I press play, this is how it's animated, right? But again, since the solver takes over at 10:10, this really I wasn't using it. I have an idea, then at the end I just changed that. So you can see the same noise, and where the follow is right here by the teeth. So if we look at the piece again, you can see that that part was not disintegrated like the rest of the skull, right? And that is why I did that. Basically, I just didn't want to affect the teeth of this skull here. And after that, if we go back to check the mask, what I did also different here, I mean, forget about this, just black here because I'm not running the solver yet. I added this tag inside geometry, which is basically just grouping something. And if we look at this, I'm basically grouping the bottom part here. And as you can see, it has a distinct line. It's because I'm using the terrain here. Let me go back here real quick, turn off a few things. That, and then also here. So if we look at this, I'm basically grabbing the intersection where this my skull intersect here to group the bottom part. And this again, the target component is face, and then the group, or actually the name of this attribute or group, because it's just Boolean data at the end of the day, is just called intersection tag. I'll explain. This is gonna make more sense later on, but I just did this here. And I remember this is face component, so I'm grabbing the faces here, no points. By default, it's point, by the way, but I just changed it. Other than that, then I freeze that. That is why the the offset animation that I didn't see, it doesn't, and it didn't make any sense. But this is also going to make faster this, so it doesn't recompute. And since also the solver is running on rest position, that animation is not taken into account. It's just going to take into account the first frame, basically 10:10 in this case. Then I created this fall off, kind of I call it fall off. Let me just hide again the terrain here, and I have these two spheres. And those are the points that I'm initializing the mask now to 1, basically, right here and there. So if we look at this real quick, we'll see that that is where basically these guys are starting getting to white. And if we press play here now in the solver, now that is where we start seeing this growth happening, right? And that's it. So in the solver, it's basically the same. I'm just setting the different properties here, transferring the attribute mask, getting the mask attribute from the starting data, then getting the mask attribute from the previous frame, getting the max from these two values, using the ramp to create a little bit of contrast, and then setting the mask attribute again in the output for the sim, and then also using the smooth geo. As you can see, it's the same. The only difference that I did in this is that I promoted all those parameters that I needed to change here. That way it's easier to change in the top level instead of going inside the solver and change all those things, right? So yeah, that's it. Then I created this tag group active that I call active here. At the end, I didn't end up using it, but what this is doing is just grouping basically the mask. So I got the mask again, the attribute the mask from the infection solver that I have, and I just say, if it's this greater or equal to 1, then put those, basically group these points. And as I said, I didn't end up using it, but you can see that this is basically matching the mask attribute very closely. And this is useful for other things. You can use groups or tags. For example, if you need to convert this mesh into a Maya mesh, this actually is going to travel through, which is very useful if you need to. For example, like to shade this differently. I mean, there is multiple ways to use this, but I didn't use it, but I wanted to show you that. And then I just catch the solver. So as we talked on the first video, and it's important just to keep the attributes that you need here. And then, yeah, I just basically catch that. I delete a few properties here that I don't need, and I just keep the most important in this case, where basically the mask, which is the main one, the intersection tag group that I created, and the active group as well. And that is catch. Obviously, you won't see anything here because we run the solver in rest position, basically. Then I'm reading the catch here. Let me bring this terminal here. All right. So what I did here, I have the animation, right? And let me delete this, or actually just hide it. Turn it off. Turn off this terminal right here. So I have the animated mesh here, right? And if we look at the attributes here, let me just open this in the data browser. You can see that we don't have the mask or active or intersection, right? We just have the attributes that came from the beginning. I deleted a few other things that I didn't need to. And then also I computed velocity here, which is going to be very important for the seams. And actually this is going to helps quite a bit for your collider. So it's always good if you have an animated mesh to compute velocity. And as you can see, we have the data. Oops, we have the data here and it's updating, so that is working great. I created UVs from the camera and that is the other camera that I have actually here. So if I go to perspective, you can see that I'm creating creating UVs from this perspective, this point of view. At the end, I didn't end up using it, but I created just in case. And this is also from Bal, our friend Bal. So if you have that library again, you will have this node. All right, so again, compute velocity, and then I created UVs from there. And what we did here, I grabbed basically the catch, right, from the solver, which is in rest, right? There's no animation here. And then I created a rest attribute here. And the rest attribute is very useful for shading, for comping, and for other operations as well. I added a little note here. Basically, we're going to be using the rest attribute, and there's a misspelling here. The rest attribute for the triplanar, but it's very useful to actually set this up, right? And since it's in basically the solver is happening in rest, we just animated attributes here. Nothing else is happening. It's the perfect spot because you want to get the rest when there is no animation, basically, if that makes sense. And then our intersection group, right? The intersection tag here. What I did here, I basically promoted this intersection tag from a face component target into a point component. And I'll explain very quickly why I did that. And if we look now at the data here, you can see that this intersection tag now is point because I promoted that from face to point. And you can target any other component here that this node allows you to do. So again, that is the convert tag node. And then Bifrost add a point underscore just so you know that it's actually a point now attribute or group or tag, right? And by default, this actually remove the source tag. That means that it's going to remove the face. So if you want to keep it, you can keep it here. So you can keep both the promoted and then also the original one. In this case, I don't need the original one, so I just say that. I just keep it as it is. And then you can rename also this to whatever you want if you don't want to keep it as a point intersection tag. I just kept the original name. And what we're doing here, basically what I want to do here is just grab these attributes. They are animated in the solver, right? On the rest solver cache that I have, and then pass or copy all those attributes into the animated mesh. And for that, we're using the attribute, the transfer property by indices. And this node, what allows you to do, basically just going to transfer those attributes from the animated mesh to the rest, and it's going to match them by these indices. And this is called sometime in other DCCs like an attribute copy, for example. And this is going to be a lot faster than, for example, using the a point cloud kind of attribute transfer, right? Or like what I was using before, which was the transfer property, which is using the get closest location and get closest point. This will be way, way faster because basically we're just transferring data one-to-one. There is not really a point calculation. Hopefully that makes sense as well. So here, the way that you do that, basically you provide a target and a source as always. So the source is going to be our basically solver cache here, and the target is going to be our animated mesh. And again, we are matching by indices here, IDs. And if we look at what I'm copying here, basically I'm just copying the mask, which is the most important one, then the active group, which I did not use, the point intersection tag, that group that we created on the bottom, and the rest position. And that get passed directly into the animated mesh. So you can see now we are looking at the after this we are looking at the animated mesh, and we have the active, mask, rest, and the intersection tag as well. Um, so this is actually useful because sometimes, or it depending really what you do, you want to do all the calculations in the solver in basically at the origin sometimes, and then just copy what you need to into your animated mesh. And by the way, also it's important to mention that this way of transferring properties, the way that it works, it needs to match basically the point count. So we have in the solver, we have 800,000, right? And the animated mesh, we also have 800,000. So that's why this works. And that's why we are not using the kind of like point cloud transfer property, or also, we have other ways to transfer properties by 2D indices, by weight sum, but we are using this one, which is the fastest. Because again, the point count is matched between the two, right? And that's why this works. I know that I'm repeating myself, but I feel like that is an important point to make. And then I did this conversion to point, right? Because I'm transferring point to point. So I'm picking the point component, I'm targeting also the point component, and that's why I did this conversion. What I could have done too is just copy and paste, or like bringing another transfer property by indices, and instead of transferring point to point, I could have done face to face, right? But since it was just one attribute that I wanted from the face, I just say, okay, well, it's easy just to convert this into a point, because at the end it's the same. I don't lose too much. And it's also a good way to use to showcase another node here, which can be useful for other operations. And then to create the disintegration, after we did that I just basically grab the mask attribute here, and I just say, well, if the mask is greater or equal to 0.1, just delete the points. And as you can see now, that is deleted. And then we are keeping the teeth, right? And then this is the last frame, or maybe a little later. I can't remember how much I catch, to be honest, but let's see, to 10, yeah, 12, 20. So like just 4 more frames. So I did end up, killing everything. I did end up doing that. So that is the disintegration. Very easy. And now, we are grabbing the static data and then transferring it to the animated mesh, and that works just great. Then to create that edge attribute, what I'm doing here is basically what I showed you before too. So we are grabbing the mask attribute. I'm smoothing that in this case by 20, passing it, grabbing the mask, doing an F curve like this kind, right? And then basically I'm just saying delete everything that is less or equal to 0.1, and then delete again the points. And that's going to give us just kind of like this white part, right? And if we look at the catch now, I'll explain this in 1 second here, but if we look at this, we have that. Now, what I did here, I created another fall off, because if I show you now this, and I'll go back here now, and let me hide the, actually I want to show you from here before we do this operation. So if I don't do that, I will get this edge where we put the fall off before in the noise, right? And then that will keep emitting from actually this area. So if we look at this, that will keep emitting around here. I mean, you probably won't see it, but still it's going to emit, and I did not want that. So basically what I did as a post process again, I grab the point position again, I grab another fall off in the same spot here, and I just say, okay, delete that if you're grading, greater than 0.1, and then just delete those points. And that is what this gives me now, that basically it's very smooth, but you won't even notice, and it's not kind of like, it just goes through, right? It doesn't get stuck as it was before. If not, the particles will be completely emitting in this side all the time, and I did not want that. And that also show you how attributes, right, are very powerful after even you catch something, because that way now with just one attribute we are doing a bunch of stuff here. We are creating a group, for example. We are actually getting an edge, a leading edge. We are disintegrating the mesh. We are then feeding this into the particle on the smoke solver, right? So just with one little attribute, the mask, we're creating a bunch of other operations, and then also we can manipulate that data after the fact. So I don't have to go to the beginning, for example, and catch the solver to do any of this. So again, this is kind of working procedurally in a way, just with attributes, and show you the power of this. Hopefully that makes sense as well. So we have now the leading edge, and also we catch the disintegration. So we have both now. So that's it. So this was the part, and then I just have an if statement here. I explain why, but this is basically just passing the data into these two outputs, because I'm not using the terminal, because I'm just then grabbing this custom solver and dragging and dropping into the smoke and particle solver. And that is what we're going to be talking about next.